Hi guys, this is LeetCoder, and today I attended LeetCode's bi-weekly challenge, and the questions was pretty good. That was not too hard. Just you have to, I mean, you just have to build the logic, and I just gave a brute code solution, and it was a little bit optimal. I don't know what's happening with the LeetCode, but I'm getting sometimes 10 ms, 14 ms, or 7 ms something. It just fluctuates. So yeah, with that said, let's get started. And I just tried many more times the solutions. Look at this. I don't know how many submissions I did today. 42. Anyways, so let's continue. Let's remove this. We don't need this. Yeah. So the question says, in a linked list of size n, you just don't know what's the size, but where n is even, the size of the linked list is even, so there will be even number of nodes, and ith node, zeroth index of the linked list is known as twin of the n minus 1 minus I. N minus 1, it is because we start counting the nodes from 0 in computer science we start counting from 0, right? So the size is 4, so 4 minus 1, that is 3. That makes sense, right? Now what is I? Suppose these two colors are blue in color, right? 5 and 1. So you can see over here, 5 and 1 makes 6, and 4 and 2 makes 6. So we have to return the maximum of these two. Or in case there will be 6 elements, then it would be among the pairs. So that this must be twin. So so let me explain with a diagram. How do you go to this? I don't. Sorry. Let's wait a second. Yeah. So suppose this is a linked list of size 6, and here will be null, right? So this and this will make pair. Let me change the color. Yeah, let's take it. This will make a pair. This will make a pair. I mean twin, whatever you can say. And finally, this will make a twin, right? Getting my point? So now what's the common thing here? This is 0th index, 1, 2, 3, 4, and 5. Sorry, and 5. So the size is 1, 2, 3, 4, 5, 6. N is 6, right? And the size is n. So n minus 1 is total number of indexes, that is index equals to n minus 1, we all know. So what will that, just to find the twin, what we can do is, twin is, suppose we are traversing from ith index to n. So it will be I, comma, n minus 1, that is size minus 1, that is the index according to computer science, minus I, because it's 0 initially, and n minus 1 minus 0, that is 5. N is 6, 6 minus 1, that is 5, and minus 0. And suppose it increments to 1. I is 1 now. So what will be n minus 1? N minus 1 will be 5. 5 minus 1. 5 minus 1 is 4. So 4, we're getting 4 here, right? Getting my point? So 1 and 5, 1 and 4, and 2 and 3. These are the index that we can find the twin. So, so what we'll do is we'll just take the size of the, we'll just calculate the size of the the linked list. So let's just initialize something. Let's just initialize a count int c is equals 0. Now let's initialize a node dummy, sorry, dummy is equals at now while dummy is not equals null. We'll just count, increment the count, and we'll just increment the node. Got it? Now here we'll get, we are counting the size of the linked list, or n. Or let's assume n. Let's make it more complicated. Okay. So we have to initialize an array over here because this was my brute force approach. So I'll initialize an array named answer ans, and this will be new int. What is the size? We don't know. No, actually we know this is the size. So will be, so this is the size of the array, and again we'll traverse, and this time we'll just take the elements from the actual head, I mean actual linked list. So we'll just initialize one more node, p is equals to head, while p dot next is not equals null. We'll just traverse p is equals p dot next. But before that, what we'll do is we'll just take ARR of j is equals p dot val. P dot val contains the value at that node. So let's also initialize j is equals 0. J is initially 0. We have to increment j also. So let's initialize that. And at the end, we have to increment j. J is equals to p dot val. Why I'm saying this? Suppose at this we are checking p dot next is not equals null. Sorry, is not equals null. So what does that means? It means if its next is not null, will traverse. So at this point, at p is over here, so p dot next is not null, so it will traverse. It is true, right? But at this point, it will not traverse because its next is null, but we are lagging this behind. I mean, we don't have this value. So just to calculate this value, we have to take j's, because the last time we just incremented j, and at that time j is 5. J is 5 over here, so we can access the last element, right? So we'll just take ARR of j, I mean that the last element, the last index of the linked list itself. We'll just take the value of the last node of the linked list. Got it? Clear? To take the last node of the linked list. Good. Now, what we'll do is we'll just take another L. L will be storing the size of the array. Okay. So int L is equals ARR dot length. So actually, wait. We don't need L, I guess. We have N. Yeah. So in for loop, we'll just start from I is equal 0, I is less than N by 2. Why we need N by 2? You may be asking, right? So why we need N by 2? Because we just need to traverse half of it. We don't need full traversal. Let me explain. Let's divide the array by 2. It's looking like red, so just ignore that part. I mean, this is really annoying. I'm sorry. So for 0, if I is at 0, suppose I is at 0, so we know with this formula n minus 1 minus I, we can get its twin, right? And if I is at 1, we are also getting its twin by this formula. And if I is at 2, second index, we are also getting is the index, the twin, the complete twin. And we are said, as said, the question is saying we are will be getting a even number of nodes linked list in the parameters, right? So we don't need to do some more complex calculations. We're just good with it. So let's not make it more complicated. We'll just iterate to the half of the array. So it will be n by 2. Getting my point? Now I plus plus. So int sum. What will the int sum? Int sum will be ARR of I. Okay, we can minimize this. Well, let's not make it more complicated. I'll make it simple. ARR of I plus ARR of n minus 1 minus I. You know this? N minus 1 minus I? N minus 1 minus I. Got it? These are the twins, n of I and n of n minus 1 minus I. N is over here array. Array of I and array of n minus 1 minus I. That is the zeroth index at this time, and this is the last index of this time. I mean, at a particular instance. So we'll just compare max. Max, or you can say like result. Let's initialize result over here. Result is equals integer. Oh, let's assume 0 because 0 is okay. We are good with 0. So we'll just use a map method. We can use if and else cases just to compare which is the max. Just to make things simple, we'll use math.max between result and sum. Getting my point? Result is over here 0. Which is the maximum? Result or the sum? It will return the maximum, and the result will point, I mean the result will be a reference to the maximum of these twos. I mean there must be something maximum, either sum or result, you can say that. Okay, so at last what we'll do is we'll return result. Let's run it. Okay, what's wrong over here? Okay, j is equals to p4. What's wrong? It's not easy. J is equals to p dot 12. Did you declare p? It is a p over here. What's wrong? Okay. Sorry. What's wrong over here? I'm letting you know. So it will be n plus 1, and yeah, j is over 0. J is 0 over here, and the size will be n plus 1 over here. J is necessarily 0. J at 0 is p dot well. Let's run again. I guess this might be the case. What's wrong? What's wrong? J is 0 at that time. AR of J cannot find. Oh, I forgot to initialize. My bad. New int. It's initialized, but what's the problem? Oh, sorry. I mean, my bad. AR. I'm really sorry about that. So yeah, I think I did some mistake over here. J int is equals to A here. Length. Yeah, but so we had to do -1 because the size of the array was +1, right? Just to take the 0th index. Anyways, so this is a solution. Let's submit it. Yeah, we got. And how can we decrease the number of, number of things? I mean, this is size, this is the last index, this is the last index, and we also know this is the size. So we can just result over here. I guess this is the force and the best solution I got till now. So yeah, that's it. So you can try this, and I've also made a post on it over here. You can check this out. So yeah, thanks for watching, guys. This is Litcoder, and I'll see you guys in the next one. Till then, bye.